Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Fauzan bin Muhammad, metric number 1200536. Today I will present to you the application of eigenvalue and eigenvector. First, I will introduce to you about eigenvalue and eigenvector. What are eigenvalue and eigenvector? To understand this, let A be an n as n matrix. A scalar lambda is called an eigenvalue of an A if Ax equal to lambda x has a non-zero solution x. The non-zero solution x is called an eigenvector corresponding to the eigenvalue lambda. This can be shown in the equation below. To further understand of this topic, let the equation A minus lambda I equal to 0. We can test whether the operational result of a matrix will be equal to 0 by calculating their determinant. Let's say we have a matrix A. With this, we can calculate the determinant of this equation. By using this formula. After solving the formula, we will get this characteristic polynomial where our eigenvalues lambda will simply be the solution to this equation, and we can simply get the eigenvectors by inputting the values to the above equation. Next, let's move to our main topic, the application of Google PageRank. What is Google PageRank? Google PageRank is an algorithm used by Google Search to rank web pages in their search engine results. It works by counting the number and quality of links to a page to determine a rough estimate of how important the website is. The more important the website, the more likely to receive more links from other websites. So, how is Google PageRank works? This diagram represents a mini internet where we have 4 website links A, B, C, and D, which take you to another web page. We will build an expression that tells us which of these links is most relevant for a particular person. For this, we will use the concept of procrastinating pet, which is a person who goes on internet and randomly clicks on web links. We can build a model which will tell us exactly how much time the pet will spend on a particular page. Let's first build a vector for A based on its link A has outgoing links to B, C, and D, but it does not have any links to itself. From the diagram, we can see that through link A, we can go to B, C, and D, but it does not refer to itself. So we have probability for A equal to 0, B equal to 1 over 3, C and D also 1 over 3. Similarly, for link B, we can see that through B, we can go to A and D only. So, probability for A and D is 1 over 2. For B and C is 0. For link C, we can go to D, so the probability is 1 for D. While for link D, A and D is 0, while B and C is 1 over 2 each. So the link vectors for A, B, C, and D is this. Now let's combine all the vectors into a single matrix, which will we get this matrix L. What we have here is the probability to land on web page from another page. Like for example, the only way to get to A is through B. So we need to know the probability of being at B, which we can get through A or D. Basically, the rank of all pages depend on the ranks of other pages. Now let's create a vector for ranks of each page. This rank matrix with probabilities of importance of each page. Initially, we make the probability of each page the same. Then the equation for finding the eigenvectors, which shows the probabilities of all the web pages important, is this equation. By using linear algebra, we can write the above equation as dot product. Then we need to iterate over the link matrix and rank vector and find the eigenvector. Instead of doing all the calculation manually, we will let the computer do it for us. We will use the Python and NumPy by implement this code. Then this is the iterations for dot product between link matrix and rank matrix. So we can see that after almost 10 iterations, our rank matrix is not changing. So we can say for random person to land on web link A is 0.12, for B is 0.24, for C 0.24, and also where the most relevant web link for this particular person is D. And that's how Google PageRank works. Next, from this topic, what we can conclude? We can say that eigenvalues and eigenvectors that we learn is the basic of computing and mathematics. Eigenvalues and eigenvectors can differentiate the website most and least important for users in Google PageRank. And lastly, we can see that eigenvalues and eigenvectors play a vital role in Google PageRank to easier search for user. That's all for me. Thank you for watching. Assalamualaikum warahmatullahi wabarakatuh.